Okay, so we want to find w is equal to f of x, y, z. We want to give a formula for the second derivative. Basically, the point of this is just to make you think about what the second derivative is. So the second derivative is the derivative of the derivative. And remember, f prime is just the gradient of f, and this is just the vector whose components are fx, fy, fz. Okay, so this is a function. If we allow different variables here, this is a different function. So for example, we could say f prime of x, y, z. What I mean is that this is now fx of x, y, z. There is a spider that is crawling to me that I hope decides to go somewhere different. Okay, so this is this right here, this is a vector. It is a function of three variables, and its output is three variables. So it is an R3 valued function of three variables. So f prime is a function. When we think of it like this, f prime is a function going from R3 to R3. Okay, now we've talked about this in class at length. If we fix three numbers, x naught, y naught, z naught, then what we get is a vector, just a constant vector, and in this sense, f prime is a function from R3 to R1. But when we let x, y, and z vary, now it's like we have a function going from R3 to R3. Okay, so now the derivative of this, the derivative of f prime, that's the second derivative. So what we want is the derivative of this vector valued function. Okay, and this is going to be a 3 by 3 matrix. I'm going to call it f double prime. I'll not write the argument because it'll get too much. Okay, so it is the derivative of this. Okay, so it is a vector valued function. The derivative of a vector valued function, the derivative of a function going from R3 to R3 is a 3 by 3 matrix. This component is the derivative of the first component. Actually, I'm going to do different colors here so we can match things up. Okay. If you look at this first component, the top row, this is going to be the derivative of the first component, the blue component with respect to x. The next one is going to be the derivative of the blue component, or the first component, the component with the blue on top of it, with respect to y, and then this component is the derivative of the first component with respect to z. Now we'll go to red. Okay, this is the x derivative of the second component. This is the y derivative of the second component. This is the z derivative of the second component. And then, where am I? Oh, whoops, I didn't mean to do that. Okay, and then this is the z derivative, or sorry, the x derivative of the third component. This is the y derivative of the third component, and this is the z derivative of the third component. Okay, so again, if we just think about the gradient, if we just think about this is a function from R3 to R3, and we know what the derivative is for that function. It's a 3 by 3 matrix with these entries here. Okay, that's all I got for this example.